Hello, everyone, and welcome to this webinar from Varjo about the most versatile and drivable concept car. And welcome, everyone. So I think we are going to get right started into this. This is hosted by Varjo and together with two of our software partners, Phiaro and LP Performance Research. And just to get you a little bit idea of what we will cover today, I want to show you a little sneak peek of the platform that has been built by Phiaro and LP Research. It's a drivable car that can help you to conceptualize and visualize new designs for new cars. And you see it here driving on the streets. So it's like a seat bug for those who are in the automotive industry. It's a seat bug that are actually driving on the drivable. And we'll cover part of this session will be about this platform itself, but we also go in more detail when it comes to the specific tracking requirements that are a challenge to solve when it comes to moving platforms. So this anyone in the audience who are working with tracking in VR when it comes to moving platform, I think you will be very interested in hearing what we have on this. Short little bit about Varjo for those who are not know us. So we are a hardware manufacturer. We are producing a virtual reality headset and with mixed reality capabilities. So we're selling, we're focused on enterprise grade headsets. So not for consumers, but for enterprises with the high demands of very high fidelity. We're based in Finland. We are our headquarters here in Helsinki, Finland. We have an office in the US as well, and we're selling right now into more than 40 markets. What's special with our headset is that we have a very high resolution display. So both of our headsets, the VR3 and the XR3 that are here on the picture, both are built on a very high resolution display that are on par with what your eye can see, so human eye resolution. And the field of view is 115 degrees across the whole screen. What's also unique is our video pass-through cameras. So the cameras that you see in the front of the VR headset that can channel the real world into the virtual reality experience. So you can mix and blend real and virtual objects into a photorealistic mixed reality experience. All of our headsets also have integrated eye tracking at 200 Hertz. So that's short about us. Me, I'm your host. My name is Marcus Olsson. I'm heading our software partnerships here at Varjo. And two of the companies that are in our software partnership program are Phiaro and LP Research. So I'm very happy to have to invite both of these companies here. Both of them are based in Japan and are working on this exciting platform. So when we saw this platform, we really wanted to make this available for all of you there to understand how the challenge that we've been working with together tightly in this collaboration. So Pratim Dutta from Phiaro, do you want to say a few words?
Hello, I'm Pratim Dutta from Phiaro Corporation. We are based in near Tokyo, Japan. And we have around 4 development centers in Japan and 1 development center in US urban. So we basically give shape to people's imagination, which in one word you can say we make design and make concept cars, proof of concept development. Apart from that, we develop new technology to make those concept cars reality. Thank you.
Great, thank you for joining us, Pratim. On your time zone. I know it's a bit hard with your time zone in Japan right now, but thank you for being there. And we also have Klaus Petersen from co-founder from LP Research. Welcome, Klaus.
Hello, thank you, Marcus, for the introduction. My name is Klaus Petersen. I'm one of the co-founders of LP Research. Our head office is also based in Tokyo, Japan. We specialize on the development of sensor fusion technology, sensor fusion algorithms and hardware, with a recent focus on tracking for augmented and virtual reality.
Great. Thank you, Klaus, for joining in for this session. And before we get into the presentation, I want to let all of you know that there is question and answers icon here on Zoom. So if you hover over your little toolbar, you get to see the Q&A session there. You can click that button and write in your questions as we go. If there's something that we're not covering clearly enough or anything, you can ask questions there. And we will get back to you in the Q&A session in the end. We will have 20 minutes in the end to answer your questions. And if you file them right away, we will answer them first. So feel free to join in on that one. And so I wanted to start off with showing this video of, that outlines the collaboration that we've done here on. So go and look at the video.
3, 2, 1.
So that gives you an idea on what you can do with this platform. You can prototype a whole new kind of cars that are not yet on the streets, and you can actually drive them around in virtual reality using our headset. So Phiaro, you've been developing this next generation development platform. Would you want to share a little bit on why you've been doing this and what is the driver behind this, and also comment maybe a little bit on why this is so valuable for your customers?
Right. So basically, as you already know, maybe we make and develop concept cars. So while making concept cars, it's evidently you have to make a platform or a chassis kind of thing on which you build up the concept. And for interior, like which you are seeing here, is the interior box, which is made for a specific concept. So for every concept, you need to make a different, interior box or different chassis or something like that. So it is, in one way, it's very rigid, because for every concept you make a different one, and it takes lots of time and money to make every time. And once you change the design, you cannot use the same platform again. You have to make a new one. So we thought we'll enable our clients or designers with something so that they can test their different design on the same platform. So it should be a flexible and modular one on which you can develop and test your designs. And one good point to make it flexible is it can adapt with the changing design. Like in different stage, when you just start with your sketches and preliminary models, you don't have anything. You cannot test it. So you have to wait till the time you make some probably, some milled prototype or some clay model or some, foam model or something. So that's a long time. That takes from the concept to that stage comes almost few months, more than a month or so. So if you have a platform on which you can put the digital data and experience it, especially if you experience it in the mixed reality domain, it is much easier for you to experience, because you can almost like touch it yourself, and you can mix and match different physical part and digital part, so it becomes much easier for you. And as it is flexible, you can test the design much faster, so you can save lots of time there. And if you can save time, you can actually put more time on your creative, you can explore more creative options because you save time on the physical part. So that's the main reason we wanted. And because we develop concept cars, and concept cars are always first time. I mean, we make it every time and there is no second time. Just one time we make it and then next time is a different one. So every time we do it, we need to develop lots of technology and lots of mechanism and even part of the design, lots of the design which doesn't exist. And we still don't know till the point we actually physically make it and put it on the platform. So having a flexible platform at hand makes it easier to do all those experiments, starting from the very beginning of the digital stage. Even when it comes to a partly built physical stage, also you can put on the platform and test it. So both ways, it's a win-win situation. You make it a digital or physical, both ways you can use it repeatedly. In that way, it saves time, it saves cost, because you make the platform only once. After that, because it's modular and flexible, you can keep changing it to adapt to your different projects. That's the main point for this.
Now that makes a lot of sense, to be reusable. And so would you, do you have any ballpark figures on how this compares to existing, like building a concept car, for example, how this platform could save money for
So
concept cars?
if we consider a full-fledged drivable concept car, which you see on some of the auto show, where you get into drive it around on the dash. So that kind of car cost anywhere from 2.5 million euro to 4 million euro in between, depending on the complexity. So if for this platform, it would cost roughly around 1.2 to 1.3 million euro. And the fact is that we put lots of experimental time on this. So it can be even second time when we make it could be even cheaper than that, which at this moment we cannot comment, but definitely, there's lots of scope on this, because we already have internalized the technology. Now from onward, we'll just add to that.
Yeah, no, that makes a lot of sense. So good savings there. So I mean, we've seen this kind of seat box, and so we work with most players in the car industry are interested in this kind of like trying out, doing ergonomic studies and all that. So when we met, we had the XR3, and I think already before that we had the XR1 version of our headset out, and I think this was a perfect fit for what you're doing. I mean, you can do this in VR as well, but with our headset, the XR3, you can now really combine both the high fidelity visuals and the readability of the interior, together with seeing your real hands, for example, which the XR3 allows you, and also very much the fact that you can see the surroundings, so that you can actually navigate and use the car on a real scenario, so you can actually drive it around on the real streets, right? So that's something that that we thought was very interesting to, and that's why we wanted to bring this case up here. So do you want to share a little bit about info on how you put this up, and describe a little bit about your platform and how you integrated with our
this platform? We wanted to enable every stage. I mean, in an organization, when some organization or some company design and start designing a car, there are lots of departments involved in it. It's not just it's researcher, designers, engineers, marketers, sales. Lots of people are involved to make one project successful. So if there is we see this platform as not just a physical platform for design, we see it as a communication platform for the whole organization. And to do that, what we did is we tried to make it flexible with a combination of off-the-shelf parts and some customized parts, so that you can make it as per your need. So it can be very much custom-made, still it can be very much flexible. Usually the custom-made things are not so flexible, but in this case, it's very flexible. You can change the off-the-shelf parts to make the wheelbase different and the track different. And because you can change the length and width as per your need, you can utilize this for different configuration of the design. And while making this, so what we did is we have put almost all the basic components of a car. Like we have a drivetrain, like if you see here at the left side up corner, this is the drivetrain, which is the motor and the motor control, battery control. Then on the right hand side, you see the steering. The steering is a drive-by-wire steering. So it can be controlled by means of software and using different kind of sensors, camera and other things, where it can sense the road condition or the drive, terrain condition, and can modify the steering torque and other things. So that way it can be possible to make a adjustable or adaptable steering so that it adapts the torque and other thing based on the environment. It can also even be adapt to the person, like the driver. If the driver is a female, she may have a limited strength, or if it's a handicapped people, he or she may have a limited capability. So with that also it can be adapted based on. Nowadays the sensor technology has progressed so much, it can actually sense the biometric data, and other thing can be fed and can be adjusted. Similarly for the user interface, we have actually incorporated touch screen and touchpad and touch screen in this. So all the UI development can be tested from the very beginning, even from a wireframe stage or even from the sketch stage. It can be put on the screen and it can be tried. You don't need to wait till the time usually the UI UX development after the design is done by the supplier, and it takes lots of time for the supplier to do it and then give feedback and put it on the vehicle or something.
So you have real touchscreen, so you can actually then interface with your real hands on the touchscreen and so on.
Exactly. And it's also possible to make it virtual. So if you want to change it, you can actually overlap the virtual contents on it. So you will actually manipulate the virtual thing, but you will feel as if you are touching the real.
That's
so
really cool.
Without even using a haptic glove, we can give that sense. And apart from that, we have also developed the battery for this, which is again developed particularly for the system. As you see in the bottom right corner, there's a small battery around 70 kilowatt hour battery. So it's sufficient for a day, not continuous drive, I'll say. If for a day's experiment, it is more than sufficient. So you can do limited trial outside, you can drive it, you can do all the software, hardware tests. And because this platform is open, it's not restricted. If you have a whole body car, it's very difficult to take out parts and put back there. And because it's open, suppose you develop a new seat, you can just put the seat on the platform and test it. If you develop something like the door, we can work out the fixed jig and fixture on this platform so that it can go at the actual coordinate or the actual place of the door, and you can actually test your physical door just before taking a decision. And this way,
can you take this out and drive it on a highway?
We can, but we didn't take the permission because it costs lots of money to get the get the permission and homologation, which is for a single like this is very difficult for us. So probably for OEM it may be possible, because they have all those things.
But you can drive it on a test track, inside on a closed area.
Where you don't need all the legalities are not there, so you can already take it on a test track. You can take it on a race track or something, and you can drive it. And it would be almost like an actual car. You'll feel as if you are driving.
Very impressive. So you said also that it's customizable, right? So you're able to kind of change the different parts of the
exactly.
So,
if you see this image on the top right corner, on the top image, you see on the right hand side there are those aluminum extruded channels. So those are all of the cell parts. So we can use different length of those components to adjust the wheelbase, adjust the wheel track. Of course, for the wheel track, the suspension system has to be, so if we have a smaller vehicle, we can just take the subframe of the smaller vehicle, then change the width of the frame and snap the subframe on that, narrower platform. So that way you can modify it. We also have plan in future in the next stage to make it on the fly, so that you change a button or you input something digitally, your wheelbase or track, and with motorized thing you can change it. That's of course need quite a bit of technological what you call some electro mechanical adjustment, but that is very much possible, very much feasible.
Impressive. So I think we should go ahead and have a look at this platform in action and see what's possible to do with this. So we have a video here where the car is driving on the left hand, and on the right hand side of the video you can actually see what's visible inside with the mixed reality headset. So you can see the touch screens there, I guess, are from the real car, which is you can see that both the touch screens are actually available in the real car and the virtual car, and it's driving around on the real streets, and you can see the interior is now all virtual and rendered in real time. So I guess you could kind of also do interactivity in this and test out things.
Exactly.
You want to say something about this as well?
Yeah, the good thing is that because now you are in a real environment, you can put digital contents, overlap the digital contents in the real environment, and using the XR3, suppose you can put a digital human in front of the car and check if the A pillar is, obscuring the passenger. So you can check where are the blind spots are there. Then both XR1 and XR3 has the eye tracking. So you can actually see how the driver is behaving, where he is looking while driving. If he is trying to operate the user interface, if he is feeling, difficulties, or if he is not comfortable with that. So you can actually test your design before taking a decision, and it can be done just in, like in hours, in few hours. Basically, you don't need to wait few weeks or something to get someone, develop the prototype and all. So it's very fast. That way it saves your time, it saves your money, it helps you generate more creative concepts because you have more time for that matter.
Nice. So you have two speakers there in the front as well. Is that two speakers there?
Yeah, those are speakers we just put for the infotainment system, so you can check the infotainment system how it's coming there.
Great, nice. So you wanted to say something about this mixed reality? How does this affect and the fact of why is it different from a static environment, or like something that is more like a static seat box? So how do you, what's the benefits here?
So in static, when people use a static seatback and use it in a virtual reality environment, the reality part is still lacking little bit, because you don't have sense of the motion, you don't have the sense of the road condition, the road feel and other thing, and it's very constrained because you just sit on the seat, on a particular seat or something. Whereas when you have this moving platform, you can actually feel it. When you drive it, you see the actual environment and you can see how the things are changing when you drive. At the same time, because you have the scope of putting different sensors in it and give the feedback to the person who is driving, so it's much more live. And because it's a mixed reality platform, we can actually put some very rudimentary shape, without detail. Just the shape, you can put it there, suppose milled out of foam or something. So you can actually feel as if you are touching the digital, data there. That is one, I would say little crude way of doing this. Other thing is we can actually use some haptic device, haptic gloves or something, put it, and when you drive it, you can actually feel the thing. So that way, mixed reality platform gives much more reality in terms of the design feeling and the judgment of the design. So you can judge the design, or you can give decision much better decision much faster. And sometimes what happens, in the higher level, in the C level, where people generally don't generally people hesitate to give their decision based on the sketches or based on the digital data. Then if you can put them on the vehicle, let them drive and feel it, you can expect a much faster decision from the decision making level, without whose decision you cannot go ahead to the next stage. So that's how it saves you.
So Pratim, I got an answer, a question here from an anonymous attendee. How is about the motion sickness and the latency for the driver? Maybe you want to comment on this right away.
Yeah, so this one, when we developed it, we had around 450 people came here and they have experienced it, and lots of them has actually driven it. And out of this 450 people, we have at the most one or two people who have this motion sickness. So I can say because of the mixed reality thing, you are into the real environment. So it's not that mismatch of the virtual reality, virtual contents and your motion. And because you are moving it, you feel it actually, you feel the physical thing. So your sense of discomfort is much less here.
Right. So this is actually like what the body senses is actually matching with the real world
Matching with the,
through
yes.
the headset. And I
Yes.
can mention that as well, that the latency from our video pass-through signal, from that it comes in till that you see it in the display, it's 20 milliseconds, which is not something that the human normally can perceive. So that's, and we've been driving this with cars before, also with together with Volvo actually, and there is not so much. The latency is very low, and so it means that you don't actually get sick because it corresponds to what you're seeing in most cases. So let's go on and talk a little bit about what kind of experiences this can bring for designers.
Right. So apart from the existing or the traditional things like styling, shape, the body shape or the fit and finish thing, you can nowadays, because most of the car, as you know, from 2030, almost every car would be electric. No, and there is this autonomous thing is also coming. So with this thing, you have a lot more feedback in terms of digital thing in the car, and because of that, you can use those digital contents much more easily if you have a virtual reality platform. So here you see the headlamp is real, the rest of the body is digital. And because you can touch the headlamp, so when you see it, touch it, you feel like you are actually touching the vehicle. Of course, in the other part of the digital thing, you cannot touch it. But if you use a haptic glove, suppose, we can give that sense also. And that's only possible when you use this mixed thing. No, with complete virtual thing is little unreal. With complete real thing is much more, it takes much more time and you cannot change it immediately. But with a mixed reality thing, you can take a decision and next day you can come up with a different thing. May not be next day, but much more faster. And in some cases, even within hours, you can change the thing and experience it. So that's why, the mixed reality thing is much more, I feel, is much more valuable in terms of your designer's design process to take a decision and come out with a better design.
It looks really great here. You can really see the details of the headlamps and everything like that.
Yeah.
Should we wrap up your session by giving you a short overview of the whole system that you built?
Right. Yep.
Oops, there.
That's good. Yeah, these are the different technology which we have used, and these are at the bottom you see the process which is involved in designing a car. So it's almost like a real scenario, real car making scenario, just that you're mixing up digital and real and digital to make the process much faster. So we have this XR technology using there for the experience part. Then we have steering by wire. Then we have electric drive system. You can use a central motor or wheel hub motor. Then we have signage on the grills. So because of the autonomous driving and car to everything, this called C2X nowadays is coming. It's like a Internet of Things, Internet of Everything, they call it. So the car can communicate with other cars and the other systems like pedestrian or database and other things. So those things also can be done here. And we have a real headlamp here, but it's not necessarily you have to have a real headlamp. You can put a digital headlamp. Then we have user interface there. We have the electromechanical system for the drivetrain. And at the bottom, you see all the process which have gone through, milling, mechanical things, electronics, texture, CMF. We have a full-fledged digital CMF in the car, which you can see from a very close range because of the very high, almost, with XR3, the 8K resolution is phenomenal. You actually feel like as if you are looking at the real thing. And with the use of haptic devices, probably you can give the sense of touch also.
That is great to hear that our resolution is feels like a real thing, right? So yeah. With that, we can take a look here on the car, how it looks like. This is, I think, is a really impressive video where you see the wheels here is actually from the real steering, from the real concept car, and this is all shot from our mixed reality headset. So it's what you actually see when you're inside the headset. But the rest of the car, the whole chassis and everything is all virtual, and it's rendered in Unity, I understand. So using a real-time rendering engine, and also using the tracking here. So This leads us in a little bit to the other, as you see, we have lighthouses here. So this kind of is a nice segue into what we've done together with Klaus and LP Research role in this. So I want to invite Klaus now to talk a little bit about the tracking and the challenges with such a moving platform as we have here. So
yeah, thank you very much. Thank you, Martin, for this very interesting talk about your platform. I think it's always great to see this very special piece of technology and how it works. It's really cool. Yeah, regarding the tracking, so of course, as this is a very special application case of mixed reality, augmented reality, we do need special tracking of the headset. So what do I mean by tracking of the headset? I mean to follow the pose, so orientation and location of the headset in order to display the right 3D content on the display of the headset, right? So as LP Research, where we are coming from for this VR tracking or AR tracking, that is because I think about 2 or 3 years ago, we started working on so-called location-based VR or large room scale tracking for VR headsets. So if you probably know the Steam VR tracking or the lighthouse tracking. So those lighthouses have a limited range in which they can, or say a limited tracking volume in which they can follow a virtual or augmented reality headset such as the Varjo XR3 or VR3, right? So in case you have a larger space than that, say 15 by 15 meters, 30 by 30 meters, 20 by 20 meters, whatever, then you need a special installation, right? And that is what we at LP Research are building, have been building for quite some time. So we do a special sensor fusion between optical tracking. So say you have a camera system that is built around the tracking space, and the inertial data, so the orientation data that is coming from the headset itself. And if you fuse those two informations together, then you get a very, say, responsive and accurate pose data for the headset, and can feed that into your rendering system and get very good quality content for the very immersive content for the user. So in the automotive industry, especially, that is important for quality control of the CAD models of a car. Say the designers have finished a model of a car, it is about to go into production. You want to see if all the fittings, everything is accurate, right? Then you would want to have the possibility to look at the car its real size, maybe collaboratively with other people working together on the same model. So you would need a fairly large tracking space in order to achieve that with several people. So that is kind of where we are coming from with the tracking. And then recently we have started to extend this, say, static tracking system to work inside a vehicle. Marcus, maybe we go to the next slide, where we can see an example of what this actually does.
Look at it in the real world. So
yeah, so here you see my colleague Toby. He's driving in Tokyo, in a part of Tokyo that's called Bunkyoku. So he's driving around and he's wearing an XR3 headset with the video pass-through. So you can see that he sees the environment, plus he sees an overlay over the environment, this virtual dashboard there in the middle. And the special thing that is specific to the tracking that we do here is that the content is stationary to the car. So if Toby moves his head left and right, the content stays at the same place. If the car drives in a curve, the content stays at the same place. If Toby moves his head while the car is driving on a curve, the content also stays in the same place. So we have a detachment of the coordinate system inside the car and the outside global coordinate system. So that is very important for in-car tracking, where you want to have some content that is stationary to the car, such as a virtual dashboard, and some content that might be projected outside of the car, which is fixed to certain waypoints, to certain points in the real world. Yeah, so I would, before I go a bit more into the detail, I would like to show an overview of the software architecture that's behind that. So we have our so-called LPVR middleware here in the center of this block diagram. So the middleware combines all the input from the sensors that we have in the system. So we have IMU sensors, we have optical tracking. So for optical tracking, we usually use ART tracking, the German company AR Tracking, which provides us with really excellent optical tracking devices. The quality is really fantastic, the precision, everything. And of course, the data that we get from the Varjo headsets. So we combine everything together to create this latency, very low latency pulse information. And we feed that to an API into the Varjo software, the Varjo base. So one specific thing that I would like to mention here is that the Varjo headsets are basically the only headsets on the market that have this kind of API where you can freely feed tracking information into the headset software. So that is really unique, and it is, I think it shows that Varjo is really, you know, innovative, thinking about innovation and thinking about the future, how, you know, through collaboration with other companies like ours or Phiaro, the what can be achieved with VR and AR is to be extended and really can be limitless in a way, because there's other headset providers such for example Microsoft HoloLens, the Unreal AR glasses, which are completely closed ecosystems, so you have no way of accessing any raw data, any sensor information, anything, or feed anything back into their system. So basically for our purposes of in-car tracking, some, you know, more complicated, sophisticated tracking applications, those headsets are basically useless. So the Varjo headsets are really the only headsets on the market where you can achieve this kind of thing. Anyway, so as output from the Varjo base, the pulse information and the tracking information goes into the usual suspects for the visualization, such as TechVis from the French company TechVis, and Autodesk VRAID, which is very popular in the automotive industry. I just wanted to say something real quick about the latency, because that was a question right earlier on. So we do, so we have a motion model integrated into our middleware, and that motion model does a prediction. So looks into the future a little bit of the head motion of the user. So using this method, we can reduce the latency basically to 0 in the best case. So the rendering latency doesn't play any role in the display process anymore. Right. Yeah, let's go to my final or one before final slide.
We also had one question here about the sunlight actually on the sensor.
Yeah, that's a tricky one for sure. So especially with Phiaro's platform, we had a lot of problems with sunlight. So yeah, the tracking, the optical tracking, it works best in a closed space, or at night. So when you don't have that much sunlight coming in, that is the reason why recently we are adding another technology to our tracking. So we're not only using the outside-in tracking. So if you have external cameras looking onto the headset, that's called outside-in tracking. But we're also using inside-out tracking. So we use the cameras that are built into the Varjo headset to find feature points in the environment of those feature points as optical tracking reference, and then fuse this optical tracking reference back into our sensor fusion system with the IMUs. Yeah, and the point, of course, is that the inside-out tracking is not so problematic in sunlight, so it works quite well even if the sun is basically shining directly onto the vehicle.
Okay, great, thanks.
Yeah.
I switched to this slide now about the
Yeah, so in this slide, I just wanted to quickly explain how this in-car tracking actually works, in the sense that the hologram that is displayed, this virtual dashboard, is stabilized to stay in the same place. So we basically use two IMUs, right? So if you think of the car driving a curve, right, then the motion sensor on the headset does not know if currently the user is turning his head or if the car is driving a curve, right? So we basically have two rotations overlaid at the same time, and the headset doesn't know which one it is. So in order to separate those two motions, we install a second IMU fixed into the vehicle as reference IMU, right? So the second IMU measures the orientation, direction of the vehicle. And well, as we know, the first IMU measures the orientation and motion of the headset. And if we build the difference, we calculate the difference between the two motions, then we essentially know the motion of the headset relative to the car coordinate system. And that helps us to stabilize the hologram in one place in the car. And of course, in Phiaro's case, it is not only this very simple demo hologram that we have in the demo video, but it is a much more refined interior model that sticks to the car when the car turns around the curve.
That is super impressive. I think we've seen a lot of interest from this from many of our customers. So overall, we work with a number of clients in different fields, and we see that we haven't been able to bring many of the cases are something that we can't talk about because the client wish to keep their innovation secret. But we see in general an interest in both from different types of vehicle. It could be anything from boats on the water. It could be moving platforms and a number of different sort of cases where we usually refer to LP Research and to do the tracking in these cases. And so, do you want to comment a little bit on the clients that you see that you're using your current technology right now?
Mm-hmm. Yeah. So I mean, the one application case, I think two application cases we've seen already. Right. One is basically showing a virtual dashboard or virtual controls to a driver of a car. Right. Then the second application case is Phiaro's case, right, where you use the tracking to support the design tool, like this, the moving seating buck, right, where you create interior models where you study ergonomics and so on in a real driving environment. And another application case would be a simulator, right? So motion simulators in general. You can see actually in the lower right corner of this slide an installation that we built together with the German Space Agency. It's basically a capsule sitting on a long robot arm. And they were simulating a moon landing or moon landing capsule in VR, right? So you would have basically the capsule really moving, and the person inside the capsule is wearing a headset. And of course, the motion of the headset is tracked using our double IMU system. So the other applications are, of course, in aircraft. So another interesting application case that we have is one system that we deployed to the National Research Council in Canada, where they have used this system inside a helicopter, real flying helicopter. Then in principle, you can also use the system on sea in a ship to stabilize holograms for orientation on the ship, for instrumentation and so on. So I think there are many application cases of that where you want to do augmented reality, virtual reality on a moving platform.
Very impressive. We're running close to the ending of the presentation, so we have 15 minutes left. So I wanted to save some time for Q&A. We have some forward-looking slides as well, but I think we should spend some time on the questions that we got. We already have a number of questions here. So please feel free to send in your questions, and we'll try to answer them. And then if there's time left, we can also look at some of the forward-looking things. So we got one question from Kimmo Kartano on the benefits of the Varjo technology: savings, design speeds, design flexibility, which are the most important values for you. So it's about the savings, where you save mostly on this with the Varjo technology.
So it's like, like it's more like a 4 wheels of a car. All the wheels are related. So one of the thing helps others. So if you want to put priority, I'll say the immense flexibility and the adaptability, which is the most prominent feature of this, because when you have an adaptable platform, you can keep adding on that. That way you can save time and cost. And if you are saving time while making this platform or while adding to this platform, you have more time to think more creative. You can put your time to do on creative thinking. So it helps both ways. No?
Great. We also got a question from Benedict Stuiksen about the price from the Phiaro platform. So how much does this platform cost?
Okay, so this platform which you see here is roughly 1.25 to 1.3 million euro, and which is roughly 1/3 to from 1/3 to half of a full-fledged concept car. But you can do almost everything, or even more than what you can do a full functional concept car with the platform.
So 1.2 or to 1.5, like 1.2 to 1.3 million,
Yes.
rough pricing. So we have also a question about how the video pass-through is calculated. So the question is, how does it decide to pass through the real headlamp elements? So you see the headlamps here on the model here is visible. We looked previously on a video that had the headlamps. I think those headlamps were virtual. So in our headset, we have a system that can measure depth. So you can actually decide which, like it's depth sorting, basically, that whichever is most closest to you, the virtual or the real will be visible. However, I think in the video that we saw, there was a virtual headlamp. So it's not.
I mean the gray car where it is driving, the headlamp was actual. The red one, the headlamp was virtual. Yeah.
So was that masked out then in VR?
Yes. Yes.
Okay, great. Then that kind of fooled me, actually. We got a question from James Overman. Does the LP Research or Varjo integration use pose augmentation, that is time warp, to reduce perception of latency? So
yeah, it does. The question is yes. The answer is yes. Sorry.
The answer is yes. So we use pose augmentation or time warp. Yes. So
yeah, dynamic time warp is being used in order to reduce the perception of latency.
Yeah. Then we have a question on what is the tracking system being used and how can I get the product for my testing? That's for you, Klaus. So
the tracking system, let's say the hardware components that we are using is one IMU sensor that's attached to the car or to the platform, this so-called reference IMU, and an external camera system in case an external camera system is used, or the inside-out tracking using the headset. The product it depends a little bit, need to communicate, but usually we allow customers to test the product before purchasing it. So if there's any interest, please contact me.
Yeah. So, but we've been using it ourselves with ART plus LP Research, but it's also probably possible to use it together with Steam Tracking plus LP Research, where the Varjo tracking system also accepts various different plugins. So we have a question from Nader Shokar. Have you built out an explicit RTK, a base over network for GPS tracking follow-up, how do you deal with GPS signal loss? So this is about the tracking. Is it using GPSs, I guess?
Yeah, actually, in the content that we showed in the presentation today, there was no, say, external tracking in the sense that the coordinates of the car were tracked globally, right? But of course, as you know, the kind of the focus today was on, you know, stabilizing content for the interior of the car. But to display content outside of the car, you need to know the global position of the car, right? So for that, we use RTK or GPS-based tracking in combination with either optical tracking. So we have cameras facing outwards from the car that track the environment of the car and again use feature points of the environment of the car. Plus we use odometry information from the canvas of the car. So we know how fast the wheel turns, what direction the wheels go. So we can basically extrapolate or calculate the displacement of the car from that and augment the GPS RTK data with that.
Then we have another question on how this tracking handling high vibration vehicles like very heavy diesel trucks.
Yeah, that is for sure a problem. So there's two options there. Yeah, so either you do a damping of the IMU mechanically, right? So you have some kind of spring attachment to the IMU that mechanically filters the vibration from the vehicle, or you do a software filter on the signal coming from the IMU. So you can have some of low pass filter, for example, on the raw IMU data that filters out high frequency noise.
Great, thanks. We've got a question from Francesco De Urso. Talking about Phiaro platform, what about the software of the HMI? Is it implemented in the virtual reality software, or the user can interact directly with the physical display?
We have both actually. So we use for virtual reality, we use Unity and use hand tracking for the interaction part. And in the real one, we use it a software called Kanji, which is mostly used in Europe nowadays, I think. So that is a almost close to the real production software, which can be used, which we are using with aid of touchpad and touch display and all.
I know that I think Qt is also working with something.
Yes,
like...
Qt also we have tried, but we have also used Qt at some cases. But in this particular case, we have used Kanji.
Okay, I think Unity you could also do something similar.
Yes, Unity also is possible. In fact, some of the display which we move, the central part of the thing is using Unity.
Yeah. It would be quite interesting in general to see, like, when you're thinking about the physical panel, to overlay it with a green screen so that you can see a real hand as it approaches and touches the virtual content. That's something that I haven't seen, but it's something that I've been thinking that it would be quite interesting. Exactly. A green screen so that you can filter it out and then have the interactions captured by the touch, because that way you can get haptic as well. Which leads us into another question about the green screening. I see several pictures with green screens. Do you use this to visualize the outside world and in combination with, for example, a virtual dashboard?
Yes, sometimes we use it. All those green screen mostly to put the real contents or the real thing in a virtual cityscape or virtual environment, things like that. Yes.
Then we have a question about if Varjo has improved the accuracy of the depth of edges. Last time I saw it, you get fuzzy edges. So I can say that we worked quite hard on specifically with the hand occlusion. So yes, the latest updates from Varjo base includes improvements when it comes to the hand occlusion. And I would say if you've used the XR1, it's different from the XR3. The XR3 also has LiDARs and sensors. So Yeah, there's been a lot of updates on that. So check in the latest Variobase 3.2, which is the latest that you can be downloading. Also, we got a question from about, are you already using any remote collaboration functionality? For instance, people seeing the same model from distance.
Yes, we currently sometimes use VRED Pro, which has a virtual room. So you can put the contents and people from different part, like not necessarily close. It can be anywhere, as long as the internet connection is strong enough to take care of the latency. So we can use in a virtual environment, and we can manipulate it also to a certain extent. That is possible. We are doing. And sometimes we are using some services where they provide virtual room where you can put your contents and check for, especially for design, meeting and decision making and things like that.
Yeah, I think in general the remote collaboration, we've seen some of our clients using that with, for example, VRED, where you can connect different PCs together and see the same content.
Exactly.
We are also using our QR code. So in Varjo, we also have a QR codes where you can sync your world coordinates, so that you could match in the real world, you could have one QR code and both headsets looking at the same QR code, and that would sync the model so that you can both see the same thing in the same place. So you can use pointing, for example, with your real finger. We also have a question here about when there is a combined solution. The question is, when can we see a combined solution of wireless Varjo and no base station tracking needed in HMD tracking? Is there something in the work? As it seems, base station and cables are a limitation on other areas of design work, architecture, etc. So we work with a tethered headset, and it is tethered, and we're working with a number of different, looking at the number of different solutions out there. We have a team of 100, and so we're always up to some research, but we can't comment on any roadmaps on when that would come or so. But of course, we see the need for wireless platforms. But right now, with the cable, we see that the most demanding customers really need to work with the cable solution for rendering. So I can't comment on that, but it's interesting the question about the no base station tracking. So our headset does have inside-out tracking. So the XR3 headset does have inside-out tracking. So there is an alternative to base stations, at least, which is not critically needed. And I think, like Klaus mentioned also, that there's some work in progress on when it comes to the inside-out in vehicle as well, right?
Mm-hmm.
So that's something that we can already provide. We're approaching the end of the session, but we have a few more questions, I guess. How are you powering when in vehicle, when computer system specs are you using to run it in the vehicle? So okay. How is the power?
Yeah, so the computer which you are seeing is a workstation grade, like some I think around 1 terabyte RAM, and not 1 terabyte, sorry, I think 512 gigabyte RAM and 24 GB, two 24 GB graphic boards. So all the power is coming from the battery, which you can see at the bottom, just behind the wheel. So that's a lithium-ion battery with 70 kilowatt hour. So we are using an inverter to generate the 110 volt for the computer and any other. All the devices are powered on board.
Right. We've also got a question here from Hamid Reza Dabar Sadek. Asks, how can you, who's a student, how can he get started with learning about these technologies? So that's I think I would recommend start working with Unity, for example, and working with 3D real-time 3D graphics engines and so, and get involved, and eventually, like our headset is quite pricey to get started for a student, I think, but there might be big chances coming up. And check out our developer program, our software partnership program, where you can also get possibly access to a developer kit depending on your project. Last question here is about, what do you think about cave systems? So cave systems is the systems where you have projection of walls and so. So I can say that they have their benefits. Of course, cave systems are something that we see a lot of people moving. Like we see a lot of our clients that are buying our mixed reality headsets have cave systems, and they want to kind of move into the other benefits of having a virtual reality headset, which is rendering close-ups, for example, is better in a virtual reality headset when you want to render objects that are close to you. And there's also other benefits that you can see mixed reality. You can take it out in the real world, for example. So cave systems have their benefits. They're you don't need to wear a headset, for example, and you can see each other in them. So there are some benefits with that as well. But that's something that we don't provide. But maybe Klaus and Pratim, you've been experiencing from cave systems, or?
Yeah, in fact, quite a few of our customers who used to use cave system now going away from there. They're either moving to a 16K display, just one screen display, and for the 3D they're going to virtual reality and mixed reality. That's what is the trend we see nowadays. Cave is more like a last decade system kind of, for automotive at least.
Okay, I think that's pretty much it. I would say we're running out of time here, so I'd like to say a big thank you to all of you who attended, and thank you for all the questions. And if you want to reach out, just reach out on these contact emails here. And I'd like to say a warm thank you to Pratim and Klaus as well for diving in on this.
Thank you very much. It was very nice.
Thank you for the nice webinar.
Yeah, thank you for your interest, everybody.
Great. So with that, thank you so much.
Bye-bye.
Bye-bye.